You know, solid is having definite shape and value because of strong intermolecular force of attraction. On the basis of arrangement of particles, on the basis of arrangement of constituent particles, we classify the solids mainly into two types. Those are crystalline solids and amorphous solids. Student, let us compare crystalline solid with the amorphous solid. On the basis of certain factors, we will differentiate crystalline solid as well as amorphous solid. So here, first of all, the two types of solids are crystalline and amorphous. Crystalline solids are those. The main constituent particles in crystalline solids are the crystals. The crystalline solids are those in which the arrangement of the particle exhibit a specific pattern. Amorphous solids are those in which arrangement of particles does not possess any particular pattern. So let us consider some points. We will study both of these by considering some points, and on the basis of these points we will differentiate both of these types of solids. First of all, the melting point of crystalline solid. These crystalline solids possess sharp, it's very important, these solids exhibit sharp melting point. They possess sharp melting point. Whereas these amorphous crystals melt down over the range of temperature. There is no specific temperature. These amorphous crystals gradually melt down over the range of temperature. So that's why here I do consider these will melt down over the range of temperature. So that melting point of the crystalline is very sharp. They melt down at the sharp temperature, and these will melt down over the range of temperature scales. So let us consider, that is about the one more important character. The crystalline solids are known as true solids. Why do these are called as the true solids? Because these crystalline solids do not show affinity to flow. They do not show tendency to flow. That is why these crystalline crystal solids are known as true solids. Here one more word we will consider, means term true solid. It's called as true solid. These are called as pseudo solids. Then next character, it is about arrangement of the particles in both of these types of solids. In crystalline solids, the particles are arranged in a particular pattern and hence exhibit a specific geometric shape. But here in amorphous, as the morpho means a form, amorph means formless. In this amorphous type of solid structures, the arrangement of the particles, constituent particles, not in a particular pattern. Hence, we do not expect particular specific geometric shape. This is how here the order of the arrangement of the particles, they possess, because of this reason, they possess a definite geometric shape. These are not having any definite shape, so no definite shape at all. Next character we will consider, it's a very important character, that is known as heat of fusion of both of these solids. What is heat of fusion? Heat of fusion is the state in it is the energy needed to melt down a unit mass of a solid of the same crystalline solid. So that here it is the energy needed to melt down unit mass of a solid. It is nothing but it is a fusion of heat. So heat of fusion, or else considered as a fusion of heat, is actually here it is a definite, and here it is not at all definite, so that here no definite heat of fusion. Then we will consider the next character, that is called as anisotropy. These are, the crystallines are anisotropic in nature. The nature of the crystalline solids is anisotropic. What is this anisotropic? And the amorphous are isotropic in nature. Isotropic in nature. See, if we consider this character, for example, we have already known that the molecules arranged in a particular fashion in case of crystalline solids. So here I represent two types of molecules, the red molecules, larger one, and at the same time the small, what you call as the molecules, like this. Again, I will consider one more row, and here one more row, like this. So just if I draw one direction here, consider it as AB, and I will follow another direction here, that is B and C. Actually, anisotropic nature of crystalline solids is nothing but the physical characters like refractive index and electrical resistance are different with respect to the different directions. So here, if you consider the AB, here on either side of the AB direction, there are different molecules, isn't it? Big and large, big and large. So that what happens here, if we consider here, here in the AB direction, in the BC, what are the arrangement of the particles here? Alternatively big and smaller particles are arranged. In AB, on either side, same type of particles are arranged. So that in different directions, there are different values of refractive index and as well as electrical resistance. That's why anisotropy means, okay, we will find different values of refractive index and electrical resistance with respect to the different directions. But anisotropy means here the values of refractive index and electrical resistance remains the same with respect to the different directions. This is what is called as one more most important characteristic feature of the crystalline solid and amorphous solid. We will discuss in a detailed account rest of the characteristic features of the these solids and their kinds in later means in forthcoming chapters. We will discuss the types of the solids in detailed account in the next class. Thank you, students.